So moving to the next slide. So now that you have all these different devices and you basically have almost everything you need to get going on a network, if you want to integrate this on wireless, why would you do this? What are the benefits? Basically, one of the benefits that have always been around for wireless is that they're easy to deploy. Typically, you can get wireless networks up and running in hours and days, versus with cable-type networks, it could take weeks or months if you're trenching fiber outdoors or something like that. And because of this ease, how easy it is to set up, you can easily add remote locations to an existing network quickly. If there's a temporary building that needs a temporary storage building or something like that, or a temporary office that needs to be added, it can be added quite easily. And also, the other thing with wireless is in addition to the flexibility that it brings, it also brings mobility, because you're not actually wired to anything. You're not tethered. You can move around. So this could bring cameras into vehicles. They could go on buses or trains or police cars or fire trucks, depending on whatever you would need, and because of the leveraging the wireless. And also there's less there's added security due to less cables and stuff like that can be cut or tapped into. And we had an application with a police department where they took advantage of because a lot of police cars have cameras on them, and they leveraged Wi-Fi technology and mesh technology and broadband technology to take that one step further, so that they could have an access point in a police car, and if some kind of emergency event happens, there's a disaster recovery situation where first responders have to get on site, so the police could show up. Each Wi-Fi equipped AP could then police car could then connect to another police car as they converge on the scene, and they can then create their own network on the fly, and then they would have like a brain car, which would have a wide area connection, whether it would be like a broadband like 4G or an RDN connection, something like that. So then they could have connection back to the headquarters too, so they could all report on what's going on, collect data, and whatever information they need. So it's pretty cool. Okay, so when you are integrating the wireless, there's important things to consider, especially those that are new to wireless. And the key things here, there's four. The first is distance, how far you need to go, and that's critical. Are you going to be going a few feet, a few meters, or are you going to be going a number of miles? Another important thing to consider is because it's RF, and RF is impacted by obstructions, you have to consider the line of sight. So are there any buildings in the way? Are there any trees? Are there any mountains? The more line of sight you've got, the better performance you can get with wireless. Not that you have to have line of sight in some technologies, but generally that's how it works. Also, you have to consider your bandwidth requirement, how many cameras you have, the image quality, the storage. Do you even know how much it's going to require? And if you don't, we can help you calculate that in a few slides. But you have to have that, be aware of that before you deploy, and make sure that the network can support the system and there's enough cameras to give you the visibility. And then finally, when you're going with the wireless, what type of wireless technology are you going to use? Are you going to use Wi-Fi technology, which is generally meant to go distances of feet and meters, and generally not supposed to go beyond 1,500 feet. So, but if that's the case, you may be able to take advantage of that because Wi-Fi products tend to be lower cost. But if you're looking at larger distances or more of a campus-wide deployment, you may want to look at broadband distribution, either point to multi-point, WiMAX type technology, or 4G or something like that. Okay, so just going to the next slide. So we just have a case here, sort of an example that we wanted to show you. We have a customer they moved in a few years ago, perhaps in this building here in the center point, and their business has grown rapidly. They've done some expansion. They actually already have, let's say, some existing cameras in place that they've been using to help give some visibility into their environment. So they've cabled these in here. These are just dome cameras. They might be PTZ. Everything's working fine. But then due to their growth, they decided to purchase more buildings outward here. So they end up owning all of these buildings. So they've grown immensely, and they want to still be able to utilize cameras. So they've decided, and they've done some calculations, and they've come up with that they want a number of cameras at this location. There could be 20 here, but we're just having multiple ones just for the example. They could have a bunch at this location here as well. So they've decided that they've figured out the number of cameras that they want to use, and then they have some smaller buildings over here that they're just using maybe 1 or 2 cameras. So what they've done is at the center building, they have 2 Proxim, for this example, base stations. These are the center hub radios that talk to the satellites in a point-to-multipoint network. And they decided that just to give themselves enough bandwidth to support all of these cameras, they're going to have 2 of them. And then they're going to utilize sectorized antennas versus omnidirectional because they want to focus their energy and they want to also minimize their interference. There's no sense in transmitting to an area that you have any cameras to. So they decided to dedicate 1 base station to this yellow zone pointing to the west, and then a base station heading to the north in the red zone, covering off the 4 cameras here. So they've done this now, and everything's good. And then, just to make sure that we have the connectivity on the wireless side, we have the subscribers installed in each of the locations. We have 2 versions here. We have the full-blown 300 megabit subscriber, which would support a very large number of cameras. And then to be more cost-effective, if you've only got 1 or 2 cameras that you need wireless connectivity to, we have a low-cost CPE that runs at 100 megabit versus 300, but it's a lower price point. So you can deploy whichever subscriber you think would be suitable, depending on the number of cameras. So there you have it. So looking at that example, basically the different components that we used were for the cameras, we used the Axis model for the fixed, the Axis model 207, and then to utilize PTZ and the Axis 215 camera we had there. And then for our radios, we had the 2 of the rugged outdoor base stations, the Proxim MP8100 BSURs. They take advantage of MIMO technology. They're the fastest standard out there, the 802.11n technology, which can go up to 300 megabit. And then for the subscribers, we had the MP8150, which was the fast 300 megabit version, and then we had the low-cost 100 megabit MP8150 CP. And then, of course, just to tie everything together, you'd have a switch, and ideally you'd want a PoE one. That way you can run your data and your power over the same cable. You don't have to have 2 cables per camera or 2 cables per access point. Okay, so then when you want to calculate your bandwidth calculations, basically what we do is we consider network bandwidth. How much is the camera's going to need? Typically with cameras, the average out there in the market is 2 to 4 megabits. But now that they are evolving, and you're seeing cameras now that can do HD video and 1080p type stuff, so they can use up to 12 megabits potentially. So just be aware of that. Just know what the bandwidth requirements are of the camera, and usually the vendor can tell you that. So you would calculate your image size. So which typically, let's say, a lot of people use 640 by 480, and each page, each frame would take about 32 kilobytes to do that. And so you go by times that by 8 bits, and then times that by your frame rate. In our example, we use 8, and then that would give you network bandwidth. So basically, the calculation would be 32 kilobytes times 8 bits times 8 frames per second. That would equal 2,048 kilobits, and then you convert that. That would be 2 megabits per second. So for this particular remote camera, the network would have to support 2 megabits. So if you have multiple ones, if you have 3 of them, it would have to support 6, and so on. Okay, so then you also have to calculate your storage requirements. So basically, I'm sure you know that video would require a large amount of space when you consider each frame taking up even 32 kilobytes. Then you have to decide how long you want to archive your data. Most people, when they first out the gate, they decide that they want to have 30 days, but typically we find that after they consider the storage requirements and the load on the network and everything else, they usually decide that 1 to 2 weeks is adequate. For an event to happen, for them to be able to go back 14 days is usually good enough to be able to look at an archived video. So basically, you just put in the numbers here: the image size, quality, the frame rate, the time, 3,600 seconds in this case, which is 60 times 60, 60 seconds by 60 minutes per day, or 3,600 seconds per hour. You would want to consider if there's motion in the mix. Are you just looking at static images or just looking at a building, making sure that it's it's safe, it doesn't catch fire or anything, or is there going to be people, is there going to be activity involved? So if you find there is going to be some, just figure out what the percentage is. You know, if there's half the day, there's going to be activity, but the other half there isn't, so you'd go with 50% motion. Or if there's only a quarter of the day, you'd go with 25% motion. So when you put all in these numbers, you would come up with the number of cameras and the storage requirement per day. And if I go to the next screen, I put all the numbers in here, 32 kilobytes for the image quality, and you put all the numbers into these tables and factor in all the data, and it would turn out that if you were to record 24 hours in the whole day, it would turn out that you need about 300 gigabytes of storage. So you know there can be quite a lot of video stored there. Okay, so whoops. So some of the manufacturers that we recommend in our examples here, we referenced Axis. They're very good at providing, making cameras, and they have all the features that you could possibly need. And then for the wireless infrastructure, we find Proxim very good. They're a broad portfolio. They do Wi-Fi, they do point-to-multipoint, they do WiMAX, they do broadband point-to-point links, long range. They do licensed radios as well. So pretty well, if you have any kind of application that's involved in wireless, they have some type of radio that can fit the bill. And then also we recommend the video management software from ONSSI. They're very good. Pretty well, you know, we've had training on the software. If there's anything that a camera can capture, the software can archive it and do all kinds of neat things with it. So if you so we recommend it completely. And they offer great training as well. And then to tie everything together, to be able to put cameras and radios all in the same enclosure if you're going outside, even dome cameras. We have enclosures, these interesting enclosures by DotWorks that are very ruggedized. They can bear the elements, and they're tamper-proof and vandal-proof and work really well. So for everybody that was here that was in attendance, we have just a quick little promotion. If anybody has a video surveillance project that they're working on, we can, if anybody, you know, if you get the equipment through us, we can offer 2 free hours of pre-configuration services. So, you know, if you need any more details, you can contact your rep, or, you know, if you have any other questions that don't get covered off here, you can always contact us for more details as well. And my contact information is here on this screen if you need to get a hold of me. So, yeah, so I guess what we'll do now is move to the questions, and there's been a few of them already. So the first question was, there's a gentleman who wanted to know if they could get a copy of the slide. Absolutely. What we're going to do is that you don't even have to request it. Anybody that was in attendance today, we're going to follow up with a PowerPoint, and we'll get that to you. Okay? And also, there was a question about whether ONSSI does do audio. Yes, they do. So as long as the camera that you're deploying supports audio, has an audio feature, there are cameras out there that do that, of course, the ONSSI will be able to record that as well. So that's it. I think that's all we have as far as questions. If there's any other ones, go ahead and ask. But hopefully this was, you know, a quick overview on video surveillance, and that you guys were able to get within a half an hour, were able to get some good information. But of course, if you need anything else, you can always, at a more convenient time, whenever it's convenient for you guys, give us a call, email us, call us on the phone, come visit us, ask us about this stuff. We know a lot. Okay, so thanks very much, guys.